So I'm guessing we are live. So hi everyone. Today, what day is it today? Anyway, that's a quarantine for you, and excuse my quarantine here. But I'm glad to be introducing the one, Masimushai, who will be speaking to us about TypeScript. So introduction to TypeScript. And if you didn't know, this is developerISH, and this is an initiative where we have workshops every so often. This is the third one, and we have I'll share in our chat our link to our blog, and this is a unique one as well because we are also having a collaboration with Developer Circles Mombasa. So stay tuned. At the end of this, we'll have a Q&A, and we also have giveaways. So that's awesome. I'm glad. I hope you're excited. So with no further ado, let's have Masimushai.
Thank you, Stan. Hi, everyone. My name is Masimushai. I think some of you on the call know me. I'm a software engineer, and I'll be doing an introduction to TypeScript today. So I'm just going to cover a few things. I know some of the people on the call have worked with TypeScript, but for those who haven't, we're going to look at what TypeScript is. We're going to make some comparisons of JavaScript versus TypeScript. We're going to look at common data types in TypeScript, what interfaces are, how to convert a simple JS file to TypeScript. We're going to look at teams that currently build with TypeScript, and then we'll go to the Q&A. So what is TypeScript? TypeScript is a superset of JavaScript. So if you have a background in JS, it's very easy to learn TypeScript. It offers optional static typing for your code, which we're going to look at. TypeScript is open source, and it's an OOP language built by Microsoft. It's been public since 2012. I went through their Twitter and found their first tweet in October 2012. Just a background on JavaScript. JavaScript, unlike TypeScript, is dynamically typed, which is what TypeScript brings to the table, the static typing versus JavaScript's dynamically typed in sense. JavaScript was first built in '95. It's known as the language of the web. Most people who do web development, you have worked with JavaScript. JavaScript is based on ECMAScript, which is a standard that is used for web scripting implementation. And we have ECMAScript versions, which is known as ES, every year since ES6 2015. The first ES version was in '97. So why TypeScript? As I said, TypeScript gives optional static typing, which allows you to create interfaces and types for your code as you define it. We're going to look into that. TypeScript is compiled into JavaScript. And because of that compile time, then we have the benefit of being able to see all your type-related errors at compile time. In many ways, this reduces the number of errors you'll see at runtime. For JavaScript code, you view your errors fast at runtime, including the data type errors. So it makes it easier when you're coding in TypeScript to be able to have a simpler way of writing code. Some shortcomings of JavaScript over TypeScript, excuse me. So JavaScript is dynamically typed, and TypeScript, as I said, has optional static typing. So in large code bases, when you're building in JS, you write a lot of variables, a lot of functions, and this leads to a lot of potential mistakes in large code bases. But this is the benefit of TypeScript because there's the strictness that comes with typing, which makes it that as you scale, it's easier to to grow even in a bigger team. TypeScript is more predictable than JavaScript. I think in any team or even an enterprise team, you want to have predictable code, as predictable as it can get. In JS, tracing change for your code base is a bit of a nuisance. And in TypeScript, it's easier because of the interfaces and types. You can be able to trace through your code and see what's going on. There's also the refactor benefit when you're refactoring code that TypeScript has over JavaScript. TypeScript offers really powerful developer tooling where you can just get a lot of hints for interfaces and types that have been used for your functions, objects, and you can easily understand them and refactor. Other benefits of using TypeScript is that it's said to be self-documenting. This is because when you write code, you can easily review someone's code and just hover through and read through and understand what the inputs are and what the outputs are and what they're expected to look like in terms of structure. So in that way, you can be able to read through what the code is doing. TypeScript is more scalable because at a design level, you'll need to design your types and interfaces early. And then as you scale, you can always update those. And in that way, you can easily scale your code. I think this is a really good benefit when it comes to open source teams because anyone can really create a PR to the code base. And with TypeScript code, I think it's easier to review and understand. Let's say if someone creates a PR and you want your code base to be in a certain structure, TypeScript is easier to scale in that way. Another benefit of using TypeScript is when you're using schema-less databases like Firebase or Mongo, where the schemas are really fluid and anything goes, you can use TypeScript on a code base level to enforce the integrity of your DB. So this works well when you're writing, like doing a create or update. You can enforce certain things using the interfaces and types when you're writing your code. This makes it easier when you're reading from your DB because let's say you want to read some things that are really specific. You can ensure that because you wrote it in a certain structure, you expect when you're reading it, it's in the same structure. A few other benefits is what I said about developer tooling, the hints, and also the fact that TypeScript is open source and it's currently used by over 2 million people. So that makes it easier to have a community to be able to read through your code, and you can even create a PR or an issue depending on what you see when using TypeScript. So we're going to go through some common data types. I think for anyone who has used a language that has data types like Java or C and C++, you know some of these. So we have strings, numbers, booleans, arrays which take the element type, enumerators, which is a set of named constants, tuples or tuples, which we don't have in JavaScript. But in TypeScript, what they are is just an array with a locked size and defined types. The any type, we're going to look into this. The any type is literally any type. Void means no type at all. It makes more sense for functions and variables. We're going to look into why. Objects, which take the shape of dictionaries, keys, and values. Never, which is kind of difficult to wrap your head around, and advanced types, which you can look at later. So I'm going to go ahead and share some code base and go through these common types. I hope you can see my VS Code.
Yes, you can.
Okay. So some common types, the Boolean type, this is how you define types in TypeScript. You just initialize whatever variable or function, and then you assign its type, and then you give it its value. So in this example, we have is authenticated, which is a Boolean. When you hover, you can see the hint of what it expects. When reassigning it, it only expects that you would give it a Boolean, and it gives you the errors if it sees that the type is not the same. We have a simple number here, which is of the data type number, which takes integers and floats. The string data type, which we all know what strings are. The array data type takes an element type. You can either define it in this way, array, and then you pass in the data type, or you pass the data type and then you annotate the array that it's an array. So we have an example of an array of numbers here, which would only take numbers. We have an array of objects which takes just one object. And then this is the other way of defining an array data type, where you write the data type and then you assign that it's an array. So this is an array of strings. And then what I was saying about tuples, they let you define the exact size and the exact types of your array. So in this example, we expect that this is an array with two values, where index 0 is a Boolean and index 1 we have a string. So for example, if we were to change this into that, this would not work because it expects that the string comes second and the Boolean comes first. So that is the other strict benefit of having tuples. We have the object data type, which lets you define key value pairs. So here we have a dictionary which takes which is an ID, is logged in, and name. You can easily use interfaces to strictly define the structure. For example, in this case, when I change the ID to a string, nothing happens. But I have a defined interface here called user, which takes an ID of type number. Email, this question mark means that this field is optional. And when you hover over, you can see what that looks like. Is logged in is a Boolean, and name takes either a string or null. This means or, which is a union type. So for example, we can give this the interface user, and we have this error because it expects that the ID is a number and not a string. And then we can always give it an email, which was an optional field. Or we can avoid giving it, and that's just totally fine. Enumerators define the set of constants. When you don't manually give them numbers, they just take values from 0 all the way, they're just numbered. So if you wanted to give your enums values, you would define them in this way, like line 47, or just give them the values. Any allows any type. So in line 56, you see I have an array of different types. In line 57, I initialize a random string, which I later reassign to a number and then a Boolean. So this type any is what is said to be the optional static typing of TypeScript, because in this way, you can be able to let any function or let any object variable be anything you want it to be. This is useful for you when you're starting out in a project and you're not sure what the structure of your interfaces or types would look like. So it would be useful to just give it type any, move on, and then later come back to it and define it. Void means no type at all. It's used especially when your return type is, you want to ignore whatever the return type looks like. In this case, I have a simple function called read, which returns a void console log. It makes sense to use void for functions, as I was saying, versus variables, because with variables, if you're going to define it as void, you might as well use null or undefined because that's what it resolves to. So it's easier to use the data type null or undefined for variables if they are no type at all, because they would just resolve to that. Undefined, I'm pretty sure we all know what that is. The null type is empty, means empty, and I have a simple function here called profile. It takes a first name and a last name, which is optional, which is either a string or null. And you can see when I'm calling the function here, I can either give it just a first name or a last name which is a string or null. If I don't give it this, I know we would expect that this would console log the first name and then undefined because there was no value. The never data type is used is a return type for a function that never returns, for example, recursive calls, or one with unreachable code, or when you're throwing a new error. And it also is used when you want to do an exhaustive check for where not all code paths return a value. I'm going to just show you an example here where not all code paths return a value. This function, line 91, called check, takes a key which is optional of either number or string. When it's a number, it returns true. When it's a string, it returns false. So assuming I didn't have this else, then it would mean that not all code paths return a value, because if I did not give this function a parameter, then an argument when calling it, then we wouldn't have anything happening here. We'd expect an error. So I am defining an exception here of type never, which throws a new error, the message. And then I'm having that as the else for when the key is not provided. We'll look into that when we are running the code. The other thing about TypeScript is that it has very strong type inference. You would see when we are highlighting. So if I initialize a number b, a variable b, which is of type number, without assigning it a number, in this way, it already assumes that this is a number. So I cannot reassign b to anything else that is not a number because of that. So as I said, TypeScript compiles to JavaScript. When you install TypeScript using npm, it comes with a compiler, which is TSC. And you can run the TypeScript code in this way. It would output a JavaScript file at the same location. If you didn't want it to be at the same location, you would write a config file to define your compiler options, which we're going to look at. So we see this is the JS file that has been transpiled, and we can run that here. So let's look at the output. So I was logging some enums here. I was also logging A, which was undefined. I was logging the output of read, calling read. I was logging the undefined type. I was logging the calls for profile. And you see this does the exhaustive check where it throws this exception, not all code paths return a value. So if I was, for example, to give check a string, you would have to run the compiler again to be able to output, to update the JavaScript file. And then now we can run. And now we don't have the exception because all code paths return a value for the string type. So those are the common data types. And there are more advanced data types which you can look at. I'm going to share the slide. So we've seen what an interface would look like, but I'm going to just do a small demo of what they are. They enable you to define what your entities would look like structurally, and they are reusable. and you can be able to create interfaces for variables, functions, classes. Yeah. So we are going to look at the function type interface and just normal interfaces for your objects. So I have a simple, interface here called profile, which takes profile and records. The profile is of type interface personal data, records interface secure data. So the interface personal data takes a first name, last name, and age. Secure data takes string, a string, blood group, condition, which is name and diagnosis date, which enables you to use some of the JavaScript inbuilt methods like dates. So I'm using that here in this index file, which I'm defining profiles, which is an array of profiles. So I only have one object here, and I'm initializing a new date for the diagnosis date. This happens sometimes when my editor is not sure whether this is a data type or it's an initialization of a new date. Then I have a function type interface, which enables you to define what your arguments are in terms of their type and what the output is in terms of the type. So let's say in this example, we have dimensions, which is a function type interface. It would take a width of type number and height of type number, and it outputs a string. You can always output Boolean, void, whatever you want your output to look like. So in this case, I'm outputting a string, and I have another example of a function type interface, which does not take any arguments and returns, the return type is void. So I'm making use of the dimensions function type interface, and I am returning a string. So for example, if I was to change this to just be a number, I would need to change what the interface looks like because it expects that the output is a string. Making use of the log interface where the return type is void. So we're going to just compile this to JavaScript. So another thing about the compiler, it compiles to ES3 unless you define in your config what type you want it to be, whether it's ES5, ES6, whatever you want it to be, you would define it in your compiler options. So we're going to just run this. And we see it logs the profiles, the area, and the console log over here. And we see that this is just a normal JavaScript file that has been output. Yeah. So TypeScript is also useful in classes, and the way classes are typed in JavaScript and in other languages. In TypeScript, it's just the same. You can initialize new for the classes. This is just an example of using TypeScript in a class where you have data types to define whatever objects or variables you have in your constructor or even in your methods. I'm going to talk about the compiler now because a lot of times in your code base, you don't want your JS to be existent in the same place with your TypeScript code. You want them to exist in some place like lib, dist. If you've used maybe Babel or Webpack, you know that you want your JavaScript to exist in one place so that you can be able to run it from there, like the build folder or something like that. So I'm first going to look at we're going to first look at the compiler, and then we're going to look at what declaration files are. So in this example, I have a tsconfig. How you initialize this, it should be -p tsconfig. It checks, actually, no. Sorry. You would run an init, and then it checks whether there's a tsconfig in your directory, in your folder, and then if it exists, it doesn't override it unless you want to. So this would create a config file, which helps you define your compiler options. So in this config file, I am defining an output directory called this. I have lib, which helps you make use of some built-in API declarations like DOM, ES6. I'm allowing JavaScript. My target is ES5, so that means my output will be in ES5. No implicit any is a Boolean, which if you have the any type, it would give you a warning. It removes comments for the transpile JavaScript code. You can also be able to define files. This will mean that these are the only files that will be compiled. So if I was to define this, for example, it would ignore every other file, and then it would only compile this file. Include is for including whatever TypeScript files you want, and you can also exclude certain folders or directories like node modules and any test files if you wanted to. So I'm going to just run this, which is what I had done before. Running this with the tsconfig would mean that it will follow these compiler options, and we see that there's a this folder that is created with the exact same structure as what I have here. And what exists in these folders is just the JavaScript code. Just the JavaScript code in ES5 as I had as I had defined the targets. And then you can be able to run your JS code from this folder. Yeah, so that's what the compiler options are. There are so many compiler options. I think I have linked more options from the documentation here. So declaration files help you define your interfaces and types for modules and APIs written in JS. For example, you want to make use of something like React. There's a type for that package that enables you to make use of interfaces and types for React. Also, if you wanted to write your own declaration file for a JavaScript module, you can always check here first. There are so many typed modules that already exist in an open source community, which has over 10,000 contributors. You can always make use of one of the declaration files here. So you want to use this when, let's say you want to use TypeScript and you need built-in interfaces and types for your code. And so you want to start there. And then if it doesn't exist, you can always contribute your own declaration file. This is what exists in the typed modules or packages. TypeScript is widely used, and so most of the NPM packages are already typed, and you can be able to find them in the format of @type / the package name. For example, @type/node. We've already talked about compiler options. So now we're just going to look at how to convert a simple JavaScript file to TypeScript. So I hope you can see this.
Yes, we can. Thank you.
Okay, cool. So here I have a simple, let me just pause this. I had a simple JavaScript file called index.js. I renamed it to TS to make it TypeScript. And now I want to define interfaces and types for it to make sense and to remove all the errors that are visible. So first we have a simple users empty array. I have two functions here that save user details and then one that gets all user details. The save user details takes the name, age, and date of birth, and it returns a Boolean. The get all users returns the array of users. So I'm going to start by defining what the array would look like by giving it an interface. And then I'm going to make use of this interface for the users array in that way by giving it the element type, which is of the interface. And then I'm going to give my arguments here types, string, number, and date. And then I'm going to define the output of what this function is. The output is a Boolean, as you can see in line 12, it returns true. And then in my function, get all users, we know it returns this array. So we can always define the output as exactly that, the array of a user. And then I'm going to initialize new date because, as you can see in line 15 and 16, these are just strings. They're not of the type date. So I'm going to initialize new date for line 15 and 16. And then console log that. Then, of course, we're going to run the compiler to output a JavaScript file. And then we're going to run the JavaScript file to see what it outputs. Okay, it's done. And we see that the console log is true for this. And then we see that it returns get all users, the array with the date of birth as the type date. So this is a simple example of how you would do this. But let's say if you had like a bigger code base that is in JavaScript, you would start by running tsc init after installing TypeScript so that you can have a config file that is created, and then you can define your compiler option. Because as I said, in a bigger code base, you don't want your JS compiled files to exist at the same place as your TS files. So some teams that use TypeScript, which is exciting to look at because it makes you feel happy about using TypeScript. VS Code is more than 94% built in TypeScript. Hashnode also uses TypeScript. Slack uses TypeScript. Asana, Medium, and even Wix use TypeScript. There are so many teams that use TypeScript, but I chose to give a few. Yeah. So I think I'm done with my presentation. I know there might be some TypeScript devs on this call, so in case there is a few things that I missed that you want to contribute or add, I think you can also do that during this Q&A session. Yeah.
Awesome. Thank you so much, Mercy. Yeah, I really like the bit that you incorporated the video, so it's just fluid. I guess that's easier for you as well.
Yeah, in terms of time.
Yep. So we actually have a number of questions, and as you mentioned, there are actually TypeScript developers on the call. So one of my questions has been answered already. So let's see, I'll just scroll to the first one. So a question from Moffat. When you have a typeset, e.g. user null, how is it different from making this value optional with? So wait, is that question clear? Second question is, I noticed some places the Boolean operator or is used as the pipe and in other places as double pipes. So do they have any difference?
That's a good question. I think I haven't used it in two pipes before. Let's see. I think that the OR in terms of the single pipe is used when you're defining data types, and then the double pipe is used as OR the way you would use it in JavaScript. That's what I would think, but yeah, that's what I would think.
if I can point that in, actually, when it comes to data types in TypeScript, so basically the one stroke actually means a pipe. So it means like it could be this type or the other type or the other type.
Yeah.
But the other or just for like a JavaScript operation
Or.
just means something else.
Yeah, the logical operator or is the double pipes.
All right. Thank you, Thomas, for chiming in. So did we answer the first question? When you have the typeset, how is it different from making the value optional? I guess that's the same thing, right?
Yeah, it's the same thing. And also you can enforce certain interfaces or data types to be like we have to be there by using the exclamation after defining it.
All right. Okay. And just before I forget, Hoslak had asked if you can maybe have the two files, the TypeScript and the compiled JavaScript, maybe side to side, just to see the difference.
Okay, let me do that.
Maybe you can have that shared on the screen for a while.
Yeah, so
Yeah.
So this is the JS file. And then
Yep, you can open it side.
This is the
JavaScript.
This is the TypeScript file. This is the JavaScript file. So you see in the TypeScript file, it's just JavaScript code with the two functions and the calls. And then the TypeScript file is longer because it has the definitions of interfaces. Yeah.
All right. Okay. Yeah. All right. Thank you. So there's a question from Joy. What's the difference between Joy Warugu? What's the difference between types and interfaces, and when do you choose one over the other?
Okay, so interfaces contain types and not vice versa. And so interfaces are used when you want to define your objects more structurally, more often than not when you want to define your functions with interfaces or even schemas where you want your objects to have specific types. The data types are different because they're just as simple as it's either a string, a boolean. In that way, that's what a type is. But an interface contains types because you can be able to define objects, function interfaces. Yeah. So one is contained in the other and not vice versa.
Okay.
Mic check.
Yeah.
Maybe I think maybe Joy's question was, I'm not sure, but maybe Joy can correct. So sometimes I normally see people using custom, like you want to create a custom type, like type user, which looks like an interface, like another people uses interface user, which also which is an interface. Like when do I choose to use custom type user over interface user?
Yeah, so I think interfaces are reusable and you can extend different things using interfaces, but types don't have the functionality of extending. So I think that's the difference. Someone who has used both can comment on that. But for me, most of the time I use interfaces because I always presume that you can easily extend them. Types.
Hello. So I think the big difference is that interface you can extend. So for example, if you have type user, you can't use that type. And let's say you want to create another class that extends, let's say another class. I don't have good example right now, but like one class has age, name, and whatever, and the other one has, I don't know, like the location and city. So you might want like one variable to hold both types or
interface. Like combine the types.
Yeah. So you can combine those two interfaces and merge them together. So now when you do dot, you can see all the available attributes on that. It's not easy to explain without an illustration, but I think you get the point. So you can access all the properties of all those different classes that, yeah, sorry.
Yeah, thank you for that. Thank you for chiming in. Yeah, that's been helpful.
And with interfaces, you can use the extends, basically how you would use extends to extend something, and then make use of whatever the interface was, and then add onto your new interface that you're extending from a different one.
Yeah, it seems there's a bunch of questions around interfaces and types. Well, so there's Paul Kilimo. Maybe Masu, you can just look at that and figure out if you've answered that one. Okay.
Is there a standard naming pattern for interfaces? Yes, they are normally capitalized. That's part of it. And then a lot of them are prefixed with the I, depending on the team that you're in or the code base. I've been in teams where you have to prefix with I just to make it easier to be able to recognize that this is an interface and not a type. So yeah, you can prefix them with I and then the interface type, but they are normally capitalized in terms of the casing.
Okay. All right.
But they don't have to be prefixed with I. That's what I mean.
Okay. Thank you. So there's Hoslak and Bonnie who asked about introducing TypeScript into React JS codebase or just JS codebase, so without breaking things. So what's the best practice for that?
If it's a new project in React, there is a way to create React app and then prefix it with -TypeScript, which would create the config file and the options, and then you can make changes for that. But let's say it's an existing React code base, you can be able to install TypeScript. You would have to do it manually, basically. You'd have to do it manually to create the compiler. But I think I had seen an option in the past where you can just add TypeScript easily. It's not that complex. It's not straightforward, but it's not that complex. It's more straightforward when you're starting out to prefix it with TypeScript because it would create that for you, and then you can be able to edit your compiler options. But if it already exists and you want to add TypeScript in, you would have to create the config file and then change a few things to be able to run your scripts with TypeScript.
All right. And if it's just a case to give to the development team, so the advantages of TypeScript should do, right?
Yeah.
Okay. So there's one from Calvin, who says, how do you handle a function that returns a promise?
How do you handle a function that returns a promise? Okay, yeah. So in JavaScript, how you would do it, let's say you have async and then you initialize new promise with a resolve or reject. You would do the same with TypeScript. And then you can be able to define your output at the point of defining your promise by saying it's of type promise, and then it takes the element type, whether it's any or let's say array, something like, let me share my screen. Something like this. Let's say this takes some arguments and then you want the output to be a promise, you can be able to do something like that. And then you can initialize your that makes sense. Yeah, so you can be able to define your output that it's a promise and then pass the element type here.
All right, thank you. So another question is, why don't you put the JS files in the same folders as the TS files?
I think it's easier for readability, and when you're working in a big team, there's always a directory structure that you have agreed on as a team. So if, let's say it's a React code base, you have some components, you have containers, you have some static files. You want to keep your directory structure modular, and you also want to be able to run your JS code from one place. So a lot of times when you're building for front end, you want to be able to have one output where you run your code. Like, let's say the dist folder has an index file, which contains everything that is required for the code base to run. So I think the reason is, one, structures of teams and how you want your directory structure to look like, and two, being able to run all of it from one place and being able to view the outputs from one place. It makes it way easier when you have one build directory output. I see another question that you had asked, Stan, about the difference between TS and TSX. Oh, I saw that. That has been answered. Okay.
Yeah, it's been answered by, I think, Lemayan and Brian Thiambo. Thank you. And the previous question was by Mo. So, yeah. So, well, I'm getting the next question. I'd like to appreciate everyone who's asking the questions and those who are chiming in. Yeah, we are really interactive today. That's really awesome. Props to you all. So let's see. There's one that is written. I understand that I can use TS node to run TypeScript code directly, but I've not seen this being used in production. Does it mean that TypeScript is less performant than JS? Basically, why can't I run TypeScript straight on my web server without transpiling to JavaScript?
Okay, that's a good question, Lemayan. One of the reasons is because browsers understand and can read JavaScript, and not just JavaScript, a certain ES version, and we know that ES5 is the most compatible with all browsers. And so TypeScript has to be compiled for that reason, because ECMAScript is the standard through which the web can be able to read and understand the pages, your pages. And so I think that's the reason. I've also not seen myself TS Node being run in production, but I think the biggest reason would be in enterprise, you want everything that you have written on your code base to be able to be readable, whether it's on your browser or it's Node code, it's Node. So the benefit of that is you want to be able to transpile it to old JavaScript for it all to be readable. You don't want to leave room for anything that is not compatible.
Okay, mic check.
Yeah.
Yeah, also to add on that, and I think like from the server side, which I think probably Lemayan is asking, TS Node is actually more of a development tool. It was built to actually make it easier to write your TypeScript without actually trying to compile first, then run it. It was not designed to actually like a run in production environment. So basically, it's actually more the issue of TS Node, no TypeScript. But if you want to actually try to run TypeScript directly, you can try Deno, which is actually being built, which is like a runtime that runs TypeScript directly.
Yeah, thanks. I just wanted to know how I could run it directly in a production web server without thinking about the browser. Yeah, thanks, guys.
Okay.
Awesome. And I'm being told that there are questions from YouTube. Let's see, am I getting any? But one that's been asked is, does TypeScript have any advantage over JavaScript? I think we dealt with that. So I'll ask the one who asked that to just scroll back to the beginning of the call of the live stream. Yeah. So Okay, so okay, someone is asking, that's Chris. Can you please talk about typecasting in TypeScript? And I think we'll call this as the final questions for now.
Okay, cool. I'm not sure what you mean by typecasting in TypeScript. I think maybe the comparison you're making is to other languages like Java and what typecasting is. Anyone from the TypeScript who is a TypeScript dev who would want to take that? I'd have to look.
The question is, like, for instance, I would have maybe a user, and then maybe I'm fetching from an API, and then like the type, there's a mismatch of type, and there's scenarios where you see like this data to be of type user as type custom user.
As type custom user, where custom user is not the type user.
Yeah, it could be the same. Yeah, it could be like different, but you want maybe to, it's like
to
that.
Customize the.
Yeah, to try to match the type, because sometimes, you know, I get errors, and then you say, like I normally see that fix as type use another type, like they introduce another type on that.
I think the way they do typecasting TypeScript using like the term as, right? So say, for example, you get a different type that you did not expect, and you want it to be on a different type. You can say return this this data as this type.
Although even
so when sure that's type guarding. So if I had like a data type and I'd defined it as a union type, if I wanted to use it somewhere as one of those types, then I type guard it like that. It's not typecasting.
Yeah, because it would still be of the same exact type. It wouldn't be custom.
You'd already defined.
Yeah.
All right, and there's just because it's related, there's one question I missed. At what instance do you declare your own types using declare keyword?
At what point do you
declare your own type using declare keyword?
I think that's useful when you're declaring types. When you're declaring interface, you just declare them using the interface keyword. Yeah.
Okay. All right. So this is a good time to introduce Ryan. So Ryan, could you say hello? He's going to take us through what I mentioned about having some giveaways. Yeah, he'll get the details on that. But thanks everyone. And yeah.
Thank you, everyone. I think something I want to just add is Paul, on the chat, you gave a very interesting analogy of what TypeScript is. Which
I
is
really like
awkward.
that. Yeah. Yeah.
Cool. Thank you, Stan, and thank you, Mushai. That was a very enlightening session. So we're going to be doing a giveaway for several mugs from amongst the people who asked questions. So we have a select number of mugs. We have 4 mugs to give, and we'll be spinning this wheel to know who gets a chance to get mugged.
Did you say mug or mug?
Mugged.
Oh, mugged, M-U-G, yeah.
Yeah.
That's for clarification. Thank you.
Yeah. In case you don't, I'm just going to read out the names in case you contributed, because these are the question askers as well as commenters as well. In case you contributed and you don't see your name here, please just speak up. So there's Mofat Ngike, Joy Warugu, Dennis Wanjiro, Boni Mwendwa, Paul Kiplimo, Host Nagocheng, Kelvin Chiril, Monica Kwamboka, Brian Uthiambu, James Lemayan, Zachariah Njoroge, and Thomas Nyambati. Anyone? Speak now or forever hold your regrets. Yeah?
Who's Chris?
Chris is Dennis Wanjiru.
Okay, and there's Chimezi Solomon from YouTube.
I see. Chimezi. Though I wonder what community they're a part of. It might be difficult getting them, but let's just add them in case. Yeah. All right.
Chimezi is from Delphi, Nigeria. Delphi, Abuja, Nigeria.
Okay. I don't know about the logistics for that, but let me just remove him because we're going to be delivering them here in Nairobi.
All right.
Okay, so I'll go ahead and spin this wheel 4 times, and we'll have the names of the people who win mugs. Let me just switch to my computer audio so you can hear it. Yeah, I'm just going to remove him and try it again. Dennis, congratulations. And the last one, if you're a faithful person, there's a chance to pray. Great. So the 4 people who are going to get mugged, that's Paul Kiplimo, Dennis Wanjiru, Kelvin Chichir, and Mofat Ngike. That's all. Thanks for playing.
Thank you. Thanks so much, Ryan. And congratulations to the winners. I will be able to reach you. Yeah, we'll find a way to reach you. So I think that's about it from everyone. In case there's any OB, I'd like you to speak. Someone is saying open the servers. I think it's very clear. We've seen it. Ryan, could you tell us what you're sharing?
Sure. So we thank you all for attending this workshop session. I hope it's been of great value to you. We at developerISH like to measure things to make sure we're continually improving. So we have this survey that we'd like to get your feedback from. There you'll be able to give feedback about the session, as well as give a few nice words for Mushai. You can also leave them in the chat right now, or you can also put them on the survey. This is the link to the survey. I'm just going to share it in the chat, or Stan, would you kindly do that? And then, yeah, please take your time. It's a very short survey. It will be only about 2 to 3 minutes, and yeah.
Samuel Steven is raising his hand. I don't know if you'd like to speak.
All right. Nice talk, Musha, and thanks for organizing this meetup. I'm Samuel Steven. I'm the co-lead for DevC Abuja here in Nigeria. Messi gave us a platform and an opportunity to join in on this meetup, but due to time difference, we could not be able to get most of our members to come on the platform. So Chimeze was in fact asking a question on YouTube. I don't know if it has been answered. So my question is, can we be able to have some of our questions later on if most of our members get to watch the recap on YouTube. How do we get it across to Mushai?
I think that because it's on YouTube, asking questions on the YouTube channel would be easier because I can answer and other people too can answer on the comment section.
All right, great. Thank you.
Awesome. Yeah, I think I'll personally request Paul Kiplimo to share his really good summary of what TypeScript and JavaScript, the relationship is on the chat. But other than that, thank you, everyone. We'll be ending the live and the whole call right now. So thanks, everyone. See you next time.